Okay, welcome to another Ginger Mathematician video. Haven't done one of these for a long time. I'm going to try a slightly different format. I think this will be very useful for you as well. So you see me literally do this paper right in front of you, and exactly how I would approach it as well. So this is one of the most up-to-date papers out there. It's the October-November 2019 resit paper, and this is Zone 2. So this is the paper that's done in Asia and the Middle East. It's one of the most popular videos that I put out there. It's about up to 900, 1,000 views. So I thought I'd do one a bit more up to date from last year. But you don't get to see my lovely face. But there we are. I'm sure it's worth it. So first thing, notice we have, of course, our formula sheet here. So remember to use the formula sheet. It might come in useful more with a paper 4 than a paper 2, but certainly half AB or half BC sine A could be useful in one of the future questions. Let's get started straight away. So our very first question is to find the square number. Remember, square means you're multiplying by itself. So let's have a look at our numbers. Well, 8 is 2 times 4, not by itself. 27 is 9 times 3, not by itself as well. And then we look at 49 and we realise that 49 is the same as 7 times 7. So therefore 49 is our square number, and we don't need to look at the rest. Question 2, change 3.2 metres into millimetres. Well, 10 millimetres is the same as 1 centimetre, and 100 centimetres is the same as 1 metre. Those are the facts that you should know off by heart for these exams. So if I wanted to work out how many millimetres in a metre, well, I simply do 100 times 10. So 1 metre is equal to 1,000 millimetres, and therefore to find my answer I simply take 3.2, I multiply that by 1,000 to give me my answer of 3,200 millimetres. Remember, we're timesing because we're going from a bigger unit to a smaller unit. All good so far. These questions are nice warm-up questions. Remember, standard form for our question 3. Well, standard form means that it's in the format of a times 10 to the power of n. So that's what standard form or scientific notation means. And remember that a needs to be greater than 1, greater than or equal to 1 I should say, but less than 10. So it can be 1, but it's not allowed to be 10. Now the standard way we do this is we take our decimal point, so we put it after the number because there's no decimal number here, and then we move it, so 1, 2, 3, 4, until we find a number between 1 and 10. And here we have 2.8, 0, 1. And then we see how many times we've moved the point. So we look at the number and we go 1, 2, 3, 4. So therefore it's going to be 10 to the power of 4. And we simply write that in the box just here. Make sure you put the answer in the correct box. Always worth doing. Now if we look at our next question, well, it's a very small number, so we're going to have to go the other direction, which means this number will be negative. So if we move this decimal point just once, well, we do get a number between 1 and 10. Very close to 1, but it's still between those two numbers. So we write down then 1.00209, and because we've moved the decimal point 1 to the right, we're then going to put 10 to the power of minus 1. So 1.00209 times 10 to the minus 1, and we are there. Excellent. So if you're stuck on standard form, worth revising. It came up last year, as you can see in this test here. Maybe not this next year, but I will put out a prediction video in due course. So question 4, each interior angle of a regular polygon is 170 degrees. We need to find the number of sides of this shape. Okay, well, I always tend to draw diagrams, so I draw a sort of pretend diagram. It's not the right answer, but just to visualize that this angle here is 170 degrees. So that's what the question is saying. And one thing we should know with the exterior and interior angles is that we can work out the exterior angle. So we know angles on a straight line add up to 180. So this angle here will be 10 degrees. Now, why is that particularly useful? Well, we have a formula for the number of sides. So the number of sides is simply 360 degrees divided by 1 exterior angle. And this is the way I tend to approach these kind of questions. Work out the exterior angle, and then you can work out number of sides, or the other way round. So we know exterior angle is 10, and so we divide 360 by 10 to give us 36 sides. And even though it's a 3-mark question, if you remember that formula, that will save you a lot of time in this pretty short exam of only best part of 45 minutes. So just to repeat, we find the exterior angle from the interior angle, then we say number of sides is 360 divided by that angle we just worked out, and then we calculate it has 36 sides. Nice question if you practice those questions, because the style of those questions don't change. That is an easy 3 marks. Excellent, we are going to move on, and we have a speed, distance, time question. So Zian walks 8 kilometers in 1.5 hours. She then runs 10 kilometers in 45 minutes. The first thing I notice is that the time here are in different units. So before I even finish reading the question, I think to myself, well, 45 minutes, that's the same as 3/4 of an hour. That could be useful for the later question. Now we need to find the average speed in kilometers per hour. So yeah, we want both times in hours for the whole journey. Now to work out average speed, well, it's the whole distance, or total distance. And it's worth writing these things, even if we make a calculation mistake later, we've actually then put down some working so we can get at least 1 method mark. So it's total distance over total time. So we know the total distance is 8 plus 10, which is 18. Excellent. And then we now look at the total time. And well, 1.5 plus 3/4, I'll write this separately. So 1.5 plus 3/4. Well, that's 2.25. Okay, which is the same also as 2.25 if you like your decimals. I know lots of people do. Then we look at strategies for working this out, and there are different ways of doing this. You can divide directly by 2.25. I would, however, change this to an improper fraction. So this would be the same as 9/4. Now, why am I doing this? Well, I can now look at my problem here, 18 divided by 9/4. Well, remember, dividing by fractions, you keep it, switch it, flip it. So then we can do 18 times 4/9. And this has a very nice cancellation here. 9 goes into 9 once, 9 goes into 18 twice, 4 times 2 is 8. So avoiding decimals, using cancellation of fractions can make your life a lot easier. Okay, but if you're happy to do 18 divided by 2.25, by all means, please do that. That's absolutely fine. You can probably see that's going to be 8. 8 times 2 is 16. 8 times 0.25 is 2. 16 plus 2 is 18. So you can work it out that way as well. But these questions on non-calculator paper, I always recommend using fractions. Okay, question 6. Well, as soon as we see these 2 lines here, we know we've got an isosceles triangle. Spelled in the correct way, of course. Very important spelling. Then we noticed that with isosceles triangles, if these sides are the same, well, then these two angles, x and x, also have to be the same as well, the base angles. And we also know that angles in a triangle add up to 180. So we have x plus x, which is 2x, plus 28, and that's all equal to 180 degrees. And now we've formed an equation that we can solve. I tend to use arrows when doing this. In Germany, we use Kommandostrich. That's also another way. There's plenty of different ways of approaching this. Now, I think what's the opposite of 28? Well, that's minus 28 on both sides. So we get this cancelling with this. So we have 2x, and that's equal to 180 minus 28. So that's going to be 152. Then we divide by 2 on both sides. You could use bus stop division at this point, or just think of your halving strategies, and that gives us 76 degrees for our answer. So the most tricky part about that question is making sure we set up the equation correctly, like so, and then we use our linear equation skills to find the answer. But those kind of questions, just have to think it through nice and logically. Okay, so that's question 6. So let's move on to question 7. Now, this is one of these questions you really do have to read carefully, draw a diagram, and then think about it logically. The lengths of the sides of a right-angled triangle are 6 centimeters, 8 centimeters, and 10 centimeters, and find the tangent to the smallest angle. Okay, well, we're told there's a right-angled triangle, so let's draw a right-angled triangle. Now, the longest side, that's the hypotenuse, so that must be 10 centimeters. And then the other two sides, it doesn't matter which way around we write this, is 6 and 8. And so we have two possible angles that could be the smallest angle. Now, to find the tangent of an angle, remember your formula triangles or SOHCAHTOA. So tan of an angle is equal to opposite over adjacent. So if we take this angle, for example, let's call that theta, then tan of theta is equal to opposite, 6, divided by adjacent, 8. So 6 over 8. However, it could be this angle, let's call that phi, like using my Greek symbols, why not? And this could be, well, opposite over adjacent, so 8 divided by 6. So it could also be, if I do tan phi, 8 over 6. So how do we decide which one is correct? Well, if you think about the tan graph and how it works, well, it goes up all the way up to 90 degrees and then starts at the bottom to 180 and so on. My point is that it goes up in a linear fashion upwards, or it goes upwards. So if the angle is the smallest, then its tangent will also be the smallest as well. That's my point here. It's not a case of cosine where it goes downwards. So it must be the angle which has the smallest tangent. And in this case, 6 over 8 is smaller than 8 over 6. So we can write our answer as 6 over 8, or 3/4, or 0.75, whichever you prefer. Tricky wording to the question. It's not something that's come up in that style I've seen in the last 5 or 6 years. So they do put out those A-grade questions every once in a while. Okay, next question is more standard. So Magda buys 6 apples and 4 oranges for a total cost of $4.18. Oranges cost 52 cents each. Find the cost of 1 apple. Well, if we know 52 cents is 1 orange, then to work out 4 oranges, this will be equal to 52 cents times 4, and that will be equal to $2, because 4 lots of 50 cents is $2, and then 4 lots of 2 cents is 8 cents. But you could always, of course, use normal multiplying like this over here, and that would also give you the same answer. Okay, and then we say, well, 6 apples, so let's call that 6a plus 4 oranges, which we already know at 2.08 is equal to $4.18. And like question 6 beforehand, we've now got an equation which we can solve. It's all about forming those equations correctly and then relying on those techniques you've learned for many years on algebra. So that means then that we minus 2.08 from both sides. What's the opposite of plus 2.08? Minus 2.08. So we cross those out. We get 6a. And then we take this away from here. So that gives us $2.10. Very good. Okay, and then we look at this part here and go, okay, well, we need to divide by 6 on both sides of the equation, and we can use bus stop division at this point, or a variety of different methods. I think I will use bus stop division here. So 6 into 2.10, well, 6 is into 2 goes 0, remainder 2. 6 is into 21, go 3, remainder 3. And then 6 is into 30, go 5. You could, of course, always do this mentally as well. And then we get their answer that they want the cost of 1 apple. So make sure we write the answer as 0.35 because they want the answer in dollars and not in cents. Okay, so all about formulating the question they've given you and putting it into the correct linear algebraic way. Good. So let's look at the next part. So the mean of 5 numbers is 16. When 2 extra numbers are included, the mean of the 7 numbers is 20. Find the mean of the 2 extra numbers. Okay, so if we take the first 5 numbers, they must all add up to the mean, the average, 16 times 5. So if we do 16 times 5, well, 1 times 5 is 50, 6 times 5 is 30, so that gives us 80. So that's the first 5 numbers. And if we work out the mean, or the total of the 7 numbers, well, we get 20 times 7, and that's equal to 140. Now, why is this useful? Well, the difference between these 2 numbers, which is 60, that represents the total of the 2 extra numbers. That's the difference between them, so to speak. And so the mean of those 2 numbers, if they total to 60, is simply we take 60 and divide that by 2, and then we get to 30. So it's all about using the information you're given in the question. If I know the mean of 5 numbers is 16, then their total, those 5 numbers only, are 80. The total of the 7 numbers is 140. Therefore, those 2 extra numbers make up 60 of the total between 5 and 7. So just working through it logically, trying to use the information that's given in the question. Okay, now on to some very classic iGCSE 0607 questions. The first one, of course, is coordinate geometry. Comes up almost every year on the paper 2, occasionally paper 4 as well. And this is very, very standard. With 5 marks, this is quite reasonable, but there'll be quite a bit of work involved. So we've got 2 points, coordinates 1, minus 5 and 9, 1. And we want to find the equation of the perpendicular bisector of AB in the form y equals mx plus c. Well, I like to draw a small diagram, not to scale, just to see what's going on. So 9, 1, 9 along, 1 up will be over here. Let's call that B. And then point A has 1 minus 5. So we go 1 along, minus 5 down. So that gives us A here. Okay, so this is the line that connects them, and we'll want to find the perpendicular bisector that goes through the midpoints there. So lots of things we need to work out first of all. The first thing to do is to work out the midpoint of AB. So let's do that first. Now I know there's people in my class that love the formula of x1 plus x2 over 2 and y1 plus y1 over 2. I tend to keep it more straightforward, so I look at the two numbers, 1 and 9, and I think, what is halfway between those particular numbers? And we'll get the answer of 4.5, okay? 9 plus 1 divided by 2, using the formula. Likewise, if I look at my next one, so between minus 5 and 1, well, that's going to be minus 2, because minus 5 plus 1 is minus 4. Minus 4 divided by 2 is minus 2. So we've got this point. We're going to use that later on once we've got the gradient of the perpendicular bisector. Our next step is we need to find the gradient of AB, and this is what we call rise over run. Lots of different formulae for this: y2 minus y1 over x2 minus x1, or the change in y over the change in x. These are all essentially representing the same thing. So let's take this formula, why not? So we take 1 minus minus 5, because we've got two minuses, minus here and a minus here, divided by the change in x, so that's 9 minus 1, and that works through 1 minus minus 5, two minuses make a plus, so that's a 6, and then at the bottom it's 8, and that simplifies down to 3 over 4. Now that makes sense. If we look at our diagram, it should be a positive gradient. As you can see, we do have a positive gradient here. So to work out the gradient of the perpendicular bisector, perp B, it is the negative reciprocal of the gradient that we found. What that means in real English is that we take our fraction, we flip the fraction, and then we make it a minus. So we get minus 4 over 3. That's how we go from the gradient of AB to the gradient of the perpendicular bisector. So we know the line must have the form y equals minus 4 over 3x plus c, where we don't know what the y-intercept is. However, we do know it goes through that point we worked out right at the beginning. It goes through 4.5 and 2. So we can substitute x and y into this formula. So when x is equal to 4.5, or we can write that as 9 over 2, and y is equal to minus 2, we substitute it in. So we get minus 2, that is equal to, well, we take minus 4 over 3, we multiply that by 4.5, or 9 over 2 plus c, and now it's a case of just working through the numbers that we have. So just do it one step at a time. Minus 2, well, let's times those together now. So we get minus 36 over 6 plus c. Let's pop this over here. So we can simplify that fraction. So minus 2 is equal to, we okay? I think we are. Minus 6. Let's make sure everything is done correctly here. So that's fine. Minus 2. Definitely the correct gradient. 6 goes into 36 minus 6. Definitely minus 4/3 the gradient. Definitely 4.5 the midpoint. Minus 2. That's definitely correct as well. Always worth checking your work as you go through. So 9 times 4 is definitely... is that the problem there? No, 4.5 is definitely the same as 9 over 2. That's correct as well. If you multiply those together, minus 36 over 6 gives us minus 6 plus c, and therefore c then is equal to 4. Which is different to the mark scheme. I'm just looking here, it says 14 over 3. But I feel like we've done Aha, that was the mistake there. So it's always worth checking through and seeing what we've done incorrectly. And that's because the midpoint is actually at 5. 9 plus 1 divided by 2 is equal to 5. So that is 5 there. This is also 5 as well, which means this is also 5. And if that is 5, then we get minus 20 over 3. And let's go back to this step here. So we get minus 2 is equal to minus 20 over 3 plus c. For 5 marks, I thought it would be more complicated than this. Yep, so makes sense. And we bring that to the other side. So we get c is equal to 20 over 3 minus 2. And that does give us 14 over 3. So the final answer will then be y equals minus 4 over 3x plus 14 over 3. And we're done. So it's worth checking over. I knew something didn't seem correct, so I looked over the working that I did and go, that should be 5, that shouldn't be 4.5. Okay, very good. Right, let's carry on. That is a question I'd recommend practicing a lot. Usually it's not as much as 5 marks, usually it's about 4 marks, but you know, if it's more complicated with fractions, for example, then it may be that extra mark. Now this question doesn't seem obvious where to go. If we take a factor of 2 out, so if we take 2, open brackets, 4x squared minus 9, the reason we've taken out a factor of 2 is because we now left with 4, which is a square number, x squared, which is a square number, and 9, which is a square number. And now we can use our formula of the difference of 2 squares. That is, if I have x squared minus 16, that's the same as x minus 4, x plus 4. And this also works with, say, 9x squared minus 16. It's almost the identical process, but then we do the square root of 9, which is 3, and get 3x minus 4, 3x plus 4, like so. So the reason we took a factor of 2 out is so we get every number a square number, and now we can write this into 2 brackets using a difference of 2 squares. So we get 2x minus 3 and 2x plus 3, or the other way around. So that's simply our answer for 2 marks. It's one of those topics where you simply need to spot the opportunity to use the difference of 2 squares. Okay, quick drink of water. Now we'll continue on to the last few questions, which again, all very typical kind of iGCSE questions at the top end, particularly B A grade. And so we have classic simplifying surd question, rationalizing denominator, and then a log. This can be the difference between a B and A grade on this paper, just by doing this particular page correctly. So simplifying surds, remember we can't just minus the numbers, we have to break each number down so that they have the same root number. What do I mean by this? Well, we can change root 300 into the square root of 100 times the square root of 3. We're allowed to split up surds or radicals in this way. And we do the same with root 27. So that's going to be root 9 times root 3, like so. Now the square root of 100 is 10, and we leave the root 3 alone. The square root of 9 is 3, and we leave the square root alone. And now we can minus the 2 square roots. So 10 root 3 minus 3 root 3 is simply 7 root 3, which we write in our answer box. It's a bit like 10x minus 3x equals 7x. It's that same principle once we've got root 3 with both terms in our simplification. Okay, all good. And this is a classic rationalizing denominator question. This means basically we want the bottom of our fraction to be a whole number. And the way we do this is by multiplying by its conjugate top and bottom. So if we see a 3 minus root 2, we want to multiply by 3 plus root 2. If we saw a 1 plus root 7, we'd multiply by 1 minus root 7. The reason is when we use FOIL on our brackets, the irrational parts are going to disappear and we're left with a whole number on the bottom. So let's see if this works in practice, of course. So 14 times 3, going to multiply as a single bracket on the top. 14 times 3 is 42. 14 times root 2 is 14 root 2. Now we use our smiley face or FOIL. So 3 times 3 is 9. 3 times plus root 2 is plus 3 root 2. 3 times minus root 2 is minus 3 root 2. And then minus root 2 times plus root 2. Let's go through this carefully. Root 2 times root 2 is 2. And then a minus times a plus is a minus. And the whole point of this procedure is that these two terms cancel and we're left with 9 minus 2 is equal to 7. And the top stays the same. And this is where some people lose that 1 mark, because actually you can simplify this even further. And it actually says this in the question, simplify your answer. It's trying to give you a clue there might be more to do. So let's have a look. 7 goes into everything. So 7 goes into 7 once. 7 goes into 42 6 times. 7 goes into 14 twice. So we get 6 plus 2 root 2, which is our answer. And we are done. So all good. You could also factorize this into a single bracket, but as it says in the mark scheme, both are acceptable. On to logs, not everyone's favourite topic on iGCSE, but if you learn it, if you practice the style of question, you can get those 3 marks quite easily. The first thing to remember with logs is that you can take the number at the front and put it as a power at the back. And we're going to do this with both those logs there. So we get log x cubed minus log 4 equals log 2 to the power of 4, which we know is going to be 16. It's 2 times 2 times 2 times 2 is 16. Now remember, we can always add log 4 on both sides. What's the opposite of minusing log 4? Well, that's going to be adding log 4 on both sides. So we get log x cubed equals log 16 from before, and then we add log 4. This leads us then to our first rule of logs. That is, if you add 2 logs together, that means you can multiply the numbers together. So log 16 plus log 4 is the same as log 16 times 4, which is log 64. Once you have 1 log on one side and 1 log on the other side, you can then, I don't like to use the word cancel, but you can compare the 2 terms that you have. So you get x cubed is equal to 64, and therefore x is the cube root of 64. So something times something times something is 64, therefore our answer must be 4. Classic log question, particularly towards the end of a paper 2. You're simplifying logs, you're adding logs, and then you're comparing those 2 logs on the left hand side and the right hand side. And if you're going to do IB in the future, this is certainly a topic to get your head around. Okay, moving on, we've got 2 more questions, always the trickier questions at the end, so let's keep our focus. So rearrange the formula to make x the subject. So we want to do some things to this, so we get x equals something. Okay, well, usually in these questions we want to get rid of the fraction first, but we have to be a little careful in how we do that. First of all, we need to add the x over 3x minus 5 on both sides. So if we do that, we get y plus x over 3x minus 5 is equal to 1. And then we're going to bring the y to the other side, so we get x over 3x minus 5 is equal to 1 minus y. Just a little bit of massaging so we can then multiply through by that denominator, which is going to be our next step. We're going to multiply by 3x minus 5 on both sides. That gives us x, because these cancel, equals 1 minus y, 3x minus 5. Now we multiply out the double brackets. So 1 times 3x is 3x. 1 times minus 5 is minus 5. Minus y times 3x is minus 3xy. And then minus y times minus 5 is plus 5y. So we've expanded everything out. There are no fractions. All good. We've got 1, 2, 3, 4, 5 terms to deal with. Now our second step is to move everything with x on the left hand side, everything that's not x, or not got x in it, on the right hand side. So we're going to bring this term and this term over. So we get x minus 3x minus 3, plus, but be very careful, plus 3xy is equal to 5y minus 5. I've just moved those two things around. Now we can actually simplify here. So x minus 3x is minus 2x. So we get 3xy minus 2x is equal to 5y minus 5. And now is the crucial step that I'll do over here. Well, remember, we can take a factor of x out. So we can factorize on the left-hand side into a single bracket. So we take x out. What do you multiply x by to get 3xy? 3y. What do you multiply x by to get minus 2x? Well, that's minus 2. And now suddenly we've only got one thing with x in because we factorized, which is fantastic. So then we divide through by the bracket, and then we get 5y minus 5 over 3y minus 2. And I like that because the negative numbers are written in a sensible way as well. So we get our final answer, 5y minus 5 over 3y minus 2. You could have the alternative of multiplying through by minus 1. That also works as well. A pretty difficult change in the subject. It doesn't get much more difficult than that at iGCSE. Just realizing you have to add the x over 3x minus 5 first before you do anything. That's not obvious. So well done if you got that one correct. Okay, and a probability question to finish off. So an archer fires 3 arrows at a target. The probability that the archer hits the target with each arrow is 3/5. Find the probability that the archer hits the target exactly twice. So it doesn't include 3 times, it's 2 hits and a miss. So let's think about this logically. So we need to work out the probability that actually it hits the first 2 times. So hit first 2, miss third. And then the probability of hitting first and third, but then missing second. And then our very last situation of missing the first, but hitting the second and third. Okay, so remember the probability does not change, so keep that in mind. But those are the situations that we need to work out, those 3 different situations. Hitting first 2, missing last, hitting first and third, but missing second, and then missing the first, but hitting the second and third. So if we work this out, we get the following. So hitting the first 2, well, that's 3/5 times 3/5. And then missing the third, well, if you hit the target with 3/5, then missing it must be 2/5. And we actually realised that we're going to do the same calculation 3 times over. If we hit the first and third, well, that's going to be 3/5 times 3/5. Missing the second, well, that's 2/5. And then the last one will be written in exactly the same way.